Last episode, ordinal and frequency encoding, kept order and kept width small, both learned on train. Today, the most powerful and most dangerous encoder, target encoding. It can leak the answer straight into your features if you're not careful, and I'll show you exactly how. The idea is seductive. Replace each category with the average target for that group. For churn, every payment method becomes its churn rate. Electronic check might sit high, automatic payments low. One number that says how risky is this group. Great signal. Here's the leak. If I compute a row's category mean using a table that includes that row's own churn label, then the feature partly is the answer. Train accuracy soars, the model memorizes, and on truly new data, it collapses. The feature cheated. Defense 1, smoothing. A category seen 3 times shouldn't trust its own tiny average. Smoothing blends each category mean toward the global churn rate, about 26.5%, weighted by group size. Big groups keep their mean. Tiny groups lean on the overall rate, less overfitting. Defense 2, out of fold. We split train into folds and encode each fold using the other fold's means, so no row ever sees its own label. Then for test, we use the full train map. Naive versus out of fold side by side shows the naive one hugging the labels too tightly. Here's the program. We compute a naive per row encoding that leaks, a smoothed map, and an out of fold encoding, all on train. Then a clean test mapping. Load, drop customer ID, make churn numeric 01, split stratified, random state 42. Global churn rate on train is about 26.5%. That's our smoothing anchor. Naive target mean group train. By payment method, take the mean churn. We deliberately show the leaky version. Each row gets its group's mean, including itself. We'll measure how it correlates suspiciously tightly with the label. Smoothing. Each category mean is pulled toward the global rate by a weight that grows with group size. The formula blends count times category mean plus smoothing constant times global over count plus the constant. Rare categories move most. Out of fold, a 5-fold loop where each fold's rows are encoded from the other 4 folds means no row uses its own label. We print the naive versus out of fold correlation with the target. Naive is inflated, out of fold is honest. Test mapping and the figure. Test rows take the full train smooth map, looked up, never recomputed. The figure compares naive, smoothed, and out of fold category values against the global rate line. So target encoding is a sharp knife. Smoothing and out of fold make it safe. Naive use leaks the answer. When in doubt for low cardinality telco columns, one hot is the safer default. That wraps the encoding arc. Next stage, we scale the numbers. Normalization versus standardization. Fit on train, of course. If this helped, like and subscribe for more.